Assalamu alaikum. Welcome to my channel all about chemistry. Hope you all are fine. This is me, Miss Sana, and I covered these following topics in this tutorial: shells, subshells, Auf Bau Principle, electronic configuration of first 18 elements. So if you want to learn these topics, so let's watch this complete video for better understanding the concept. And yeah, before starting, do like, share, and subscribe my channel. I need your support. So let's get started.
Quote of the day: Education is the key to unlock the golden door of freedom. So, students, the objectives of today's class are: at the end of this lesson, students will be able to define shells and subshells and write electronic configuration of first 18 elements. This is the periodic table open in front of you for better understanding. So students, according to Bohr's atomic model, the electron in an atom revolves around the nucleus in one of the circular path. This circular path is called shells or energy levels, or also we can say orbit. Students, you know that shells is also called energy level. But why? Because according to Bohr's theory, each shell has a fixed energy. So that's why shells are also called energy levels. Students, each shell or energy level is described by n value. What does it mean? It means that if n value is 1, it is K shell. If n value is 2, it is L shell. L shell means second shell. If n value is 3, so it is M shell. M shell means third shell, and so on. As the value of n increases, the distance of electron from the nucleus and energy of the shell is also increases, as you can see in this picture. As the value of n increases, the distance between electrons and nucleus is also increases. Now I am going to explain subshells. Students, shell is divided into subshell. It means that if n value is 1, shell is K, and in K shell only one subshell is present, represented by 1 S. S subshell can accommodate 2 electrons. If n value is 2, it means that 2 subshells are present, represented by 2s and 2p. S subshell accumulate 2 electrons and p subshell accumulate 6 electrons. Total 8 electrons accumulate in L shell. If n value is 3, shell is M, and M shell contains 3 subshells, 3s, 3p and 3d. S accumulate 2 electrons, p accumulate maximum 6 electrons and d accumulate maximum 8 electrons. Total 18 electrons will accumulate in M shell. If n value is 4, it means n shell contains 4 subshells: 4s, 4p, 4d and 4f. As you know that S subshell accumulate 2 electrons, p subshell accumulate 6 electrons, d subshell accumulate 10 electrons and F subshell accumulate maximum 14 electrons. Total 32 electrons accumulate in N shell. You can also see this. S subshell 2 electrons, P subshell 6 electrons, D subshell 10 electrons, and F subshell 14 electrons. Okay, students. Now, what is Auf Bau Principle? According to this principle, electron fill the lowest energy subshell that is available first. What does it mean? It means that if I want to fill electrons in subshell, so how can we fill? We fill electrons first in 1s, then 2s, then 2p, then 3s, according to this order, this increasing order of energy of subshells. Like this. This is a pattern which you are follow to filling up the electrons. First, you fill electron in first S, 1s, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, 4p, 5s, and so on according to this given pattern. Let's have an example. Students, this is hydrogen, and atomic number of hydrogen is 1. So it means only one electron will occupy, and this one electron occupy on lowest energy subshell, that is only 1s. So the electronic configuration of hydrogen is 1s1. I repeat you that, as I told you in my previous slide, that S subshell can accumulate maximum 2 electrons. But here in case of hydrogen, only one electron is present. So this one electron will go to 1s and this one electron. So 1s1. Next example, lithium. Lithium contains 3 electrons in its shell. So 2 will fill in first subshell, 1s2, 2 electrons will fill in 1s, and rest of the 1 electron is fill in 2s. So the electronic configuration is 1s2 and 2s1. Now the second example is boron. Boron has 5 atomic number. 5 atomic number means 5 proton, and 5 protons means 5 electrons. So in short, boron contains 5 electrons in its shell. So how can we write electronic configuration? 1s2, 2s2. This S subshell can accumulate 2 electrons, and P subshell accumulate maximum 6 electrons. But here in case of boron, there are 5 electrons. 2 in S, 2 in this S. 2, 2, 4. Rest of the electrons will go here. 2p, 1. So the electronic configuration is 1s2, 2s2 and 2p, 1. Now the example of oxygen. Oxygen contains 8 number of electrons. So how can we fill electrons? 1s2, 2s2, total 4. Rest of the 4 electrons will go into P. 2s2 and 2p4. The electronic configuration is 1s2, 2s2 and 2p4. Okay students, so these are the electronic configuration of period 2 elements. Lithium has 3 electrons and the electronic configuration is 1s2 and 2s1. Beryllium has 4 electrons and electronic configuration is 1s2 and 2s2. Same like boron has 5 electrons, 1s2, 2s2 and 2p1. Same like others. Students, after 2p has completely filled with 6 electrons, the additional electrons will fill in 3s subshell. S subshell has maximum 2 electrons. So the electronic configuration of sodium is 1s2, 2s2, 2p6 and 3s1. Here p subshell has completely filled with 6 electrons. Here I have a very quick recap for you. As I told you in my previous slides that if n value is 1, it means it is K shell. K shell has maximum 1 subshell and 2 electrons will be accumulated in S subshell. If n is equal to 2, it has 2 subshells, 2s and 2p, maximum electrons 8. If n is equal to 3, it has 3 subshells, 3s, 3p and 3d, and maximum electrons will be accumulated is 18. Same, if n is equal to 4, it has 4 subshells, 4s, 4p, 4d and 4f, and total 32 electrons will be accumulated in fourth subshells. In fourth shell. Okay, students, so these are the questions which you have to attempt. Students, for this given image, you have to write that which atom is represented here, what is the atomic number and atomic mass of this element, and how many electrons are represented in last shell, and also write electronic configuration for this atom. And for this given image, you have to find that how many electrons does silicon contains, how many valence electrons does silicon contains, and how many electrons can the first energy level hold.
I hope you all have understood the concepts very clearly. If you have any question, then comment me in the comment section. I will try my best to answer you. Okay, so thank you so much. It's Allah Hafiz from my side. Yeah, don't forget to like, share, and subscribe. Allah Hafiz.